Hello, I am Guillaume Marquis and I choose the second question of the list. As you can see on the board, we have a part of the result computed by R from the regression of MSFT by SP500. We also have the estimated value of betas and the standard error associated. With these two values, we can compute the t-stats associated to any kind of student test. For example, we can test if beta 1 is equal to 0 versus beta 1 is different from 0. The statistic of this test would be this value, so the estimated value of beta 1 minus 0 divided by the standard error associated. And we obtain the t-value of beta 1 here. Another thing is the p-value. The p-value of the intercept is 0.932. It means that the probability to have a more extreme value than the computed statistic is 93.2%. It's extremely high. So it implies that we are very much on the left side of the critical value, and we are definitely in the non-rejection area. It says that we do not reject the null hypothesis and the intercept is not statistically significant. On the contrary, for the SP500, the p-value is very much lower than 5%. It means that we reject the null hypothesis that the beta 1 is equal to 0, and we can say that the estimated parameter is statistically significant. With the standard error and the estimated value of beta 1, we can also build an interval of confidence at 95% for beta 1. We have here the formula and the results. The results mean that we are sure at 95% that the real value of beta 1 is between 1.135 and 2.259. Another thing that is really important to check when we analyze a regression model is the R-squared. The R-squared here is 0.3863. It means that 38% of the variation of MSFT are explained by the regression model. It's not enough. So a way to increase this number is to add some explanatory variables. But if we add some explanatory variables, we have to keep in mind that the R-squared adjust can decrease. Why? Because for the R-squared adjust, there is a penalty when we add some explanatory variables. Finally, below we have two graphs showing the distribution of the residuals. At first blush, we can say that the residuals follow approximately a normal distribution. It's really important because if the residuals are not normally distributed, the estimator stays blue, but the interval of confidence and the test are not valid. So a way to make sure that the residuals are normally distributed is to use a Jark-Barra test. Thank you for listening.